Let us see what is deadlock. Okay. Normally, whenever a process is executing in CPU, okay, consider a normal process P1 is executing in CPU. Suppose process P1 wants printer. What it will do? Process P1 will ask OS, I want printer to take printout. Then OS will see whether printer is available or not, printer is free or not. If it is not free, OS will move process P1 to wait state. This is normal procedure. Okay. Process P1 will be moved to wait state if it is not available. Okay. If it is available, printer will be allotted to P1. Okay, printer will be allotted to P1. After completing its work with the printer, P1 will release the printer. Okay, that is what we are given here. Normal mode of operation by any process is first it will request a resource. If it is allocated, then it will use the resource. After the usage is completed, it will release the resource. Okay, resource means what? Any external devices that is required by process P1 during its execution. Okay, when process P1 is in execution, what are all the external things, components or resources required? That is called the resources. Okay, whenever a process wants some resources, first it will make a request to OS. Based on its request, whether it is legal or not, can be allocated or not, whether resource is free or not. Based on that, OL will decide and allocate or not allocate the resources. Not allocation means it will move to wait state. Allocated means it will be using the resources, that also in wait state. Using the resources, after the usage is completed, it will release. This is normal mode of operation. Okay, that is what I have given in the process. Okay. Consider the third point. Okay, first point, a process request resources not available at that time, enter wait state. It may happen that waiting process will never again change the state. Okay, will never again change the state because the resources they have requested are held by other waiting process. Okay. I am giving one small example. Process P1 is requesting resource R1. Okay, process P1 is requesting resource R1. Process P1 is requesting OS, I want resource R1. Okay. R1 is used by process P2. Okay, R1 is currently used by process P2. Process P2 is requesting resource R2. And R2 is currently used by process P1. I think you're able to understand the situation. Okay. Now see the condition. Process P1 is requesting resource R1 but using R2. Okay, currently process P1 is using R2 and it is requesting R1 to complete its process. If both R1 and R2 are allocated, then only P1 can complete its process. Now consider P2. P2 is requesting R2. Okay, P2 is requesting R2, but it is currently using R1. That means what? P2 can complete its work only if R1 and R2 are available. But according to P2, R2 is not available. According to P1, R1 is not available. Okay. Now the question is when process P1 or P2 will complete its work? When process P1 or P2 will complete its work, they will never complete its work because P1 P1 is requesting R1, that R1 is used by P2. Okay. When P2 can complete its work, if R2 is allocated, when R2 will become free, if P1 is completed, when P1 can complete, if R1 is released, when R1 will be released, if P2 is completed. See, P1 and P2 cannot complete its work. This situation is called a deadlock situation. That is what I have given here because the resources they have requested are held by other waiting processes. Okay, other process is in wait state for some resources and these processes asking that resources at that time deadlock will occur. Able to understand what you mean by deadlock? We will see what are all the necessary conditions for a deadlock to occur. Okay. First condition is mutual exclusion. Already we have discussed in the process synchronization also. What do you mean by mutual exclusion? When, for example, printer is there. Okay, printer is used by process P1. Okay, printer is used by, currently it is used by process P1. When P1 is using printer, can we allow any other process also to use printer? Is it possible? No other persons are allowed to print. Okay, the request may be in wait state. All the request may be in wait state, but printer will not be given. That means what? A printer can be used by only one process at any given time. That is mutual exclusion. Mutual exclusion means what? Hold and wait. This is what situation we are seeing here. See, what does it mean? V1 is holding R2 and requesting R1. Okay, P1 is holding R2 and requesting R1. What is P2? P2 is holding R1, requesting R2. This is second condition, hold and wait. Third condition, no preemption. Already we have discussed about preemption, I think. Preemption means what? Current process will get suspended due to some other important or sensitive process. No preemption means what? Current process will not get suspended at any cost. It will complete its work or it have to complete its work. Okay, current process will not get suspended. That is no preemption. And last one, circular wait. Same example I am given. This is circular wait. Okay, circular wait. Everybody is depending upon other processes depend requesting resource, allotted to process, waiting for another resource, allotted to some other process. They form a circular wait. Okay, listen carefully. If all these four conditions exist simultaneously, surely there exists deadlock. Okay, all these four conditions exist simultaneously. Underline the word simultaneously. Then surely deadlock exists there. Okay. So if any one condition is not true, definitely there is no deadlock. If any one condition is not true, any one condition is not true means what? No preemption. If we allow preemption, definitely deadlock will not occur. If we allow hold, if we are not allowing hold and wait, then definitely deadlock will occur. If there is no circular wait, then definitely deadlock will not occur. Okay, if we allow printer to be used by more than one process, definitely deadlock will not occur. Okay. Very, very important part A question. Characteristics of a deadlock. So all these four conditions exist simultaneously. Surely their deadlock exists. Okay. We will